Hi everyone, today we're going to finish talking about radicals with the idea of solving radical inequalities. So yesterday we did radical equations, today we're going to do radical inequalities. It's very similar to equations, but you just have a couple more steps to include when you're solving. So I'm going to treat this like an equation to start. Meaning that what I'm going to do is I want to get the radical by itself. So just like we did yesterday, I want to isolate the radical first. So I'm going to subtract 3 from both sides. I end up with the square root of 2x minus 6 is less than or equal to 6. And then just like yesterday, I'm going to square both sides to get rid of the radical. Okay, so square both sides. On the left here, I end up with 2x minus 6. And on the right, I end up with 36. And now I'm just solving for x, right? So if I add 6 to both sides, I get 2x is less than or equal to 42. When I divide both sides by 2, I get x is less than or equal to 21. Now that's only part of your solution. The other really important part has to do with the radical itself. Remember that we cannot take the square root of a negative number. So we have to restrict x so that whatever's under the radical is greater than or equal to 0. And the way that we do that is we just take what's under the radical and make it greater than or equal to 0 and solve for x in this inequality. So 2x is greater than or equal to 6. So x is greater than or equal to 3. So now I'm going to combine these two inequalities together, and that is my solution. So x has to be greater than or equal to 3, but less than or equal to 21. I can do that two ways. I could write that as an AND statement. X is greater than or equal to 3, and x is less than or equal to 21. Remember, and means you have to satisfy both of those conditions at the same time in order for it to be a solution of that inequality. You can also write it as a compound inequality because basically you're saying x is between 3 and 21 inclusive. So you can actually write that as 3 is less than or equal to x is less than or equal to 21. So either of these answers are fine. They mean the same thing. But recognize what we did. I solved the inequality just like it was an equation. So I got rid of the radical and solved it. But then I also had to take into consideration that I cannot take the square root of a negative number. So what's under the radical also has to be greater than or equal to 0. So that's one of the stipulations of your solution. We'll do a couple more examples so you can see. In the next one, it's a similar type of problem. So I'm going to start by isolating the radical. I'm going to subtract 2 from both sides. And I end up with the square root of x minus 3 is less than or equal to 3. When I square both sides to get rid of the radical, on the left I end up with x minus 3. On the right I end up with 9. And so when I solve that, I end up with x is less than or equal to 12 when I add 3 to both sides. That's only one part of it. Remember, the second part is to take what's under the radical and set it greater than or equal to 0 and solve that. So we get x is greater than or equal to 3. So those are my two restraints or my stipulations of x. I'm saying that x can be greater than or equal to 3 and it has to be less than or equal to 12. I can also write it as a compound inequality. Okay, so either one of those is correct. You can write it either way. Okay, let's talk about when I have a cube root in my inequality. So here, I'm going to cube both sides because the radical is already by itself, right? So if I just cube both sides, on the left here I end up with x plus 2. On the right, I end up with x greater than or equal to, or x plus 2 is greater than or equal to 1. 1 cubed is 1. And then if I just solve this inequality, I get x is greater than or equal to negative 1. Now, this one you would say, well, yeah, but I also have to check to make sure that that radicand, or that part that's under the radical, is greater than 1. You don't, or excuse me, greater than 0. You don't have to actually do that because it's a cube root. So you can take the cube root of a negative number. So this is actually the only stipulation on that particular inequality. Okay, so only if it's a square root do you have to take what's under the radical and make that greater than or equal to 0. If it's a cube root, you don't have to worry about that. Okay. All right, and then let's talk about an application problem. It says the time t in seconds that it takes a car to travel a quarter of a mile when starting from a full stop can be estimated by using that formula where W is the weight of the car in pounds and P is the power. Quarter mile time from a 3,590 pound car is 13.4 seconds. How much power does its engine deliver? Okay, so we're substituting into this formula that they gave us. So we have T is equal to 5.825 times the cube root of W over P. Okay, cube root of W over P. So I'm going to substitute in for T and I'm going to substitute in for W. I have 13.4 is equal to 5.825 times the cube root of 3590 over P. Okay. I want to get rid of that cube root, so I am going to cube both sides of my equation. I'll change colors here. Remember, this is just like what we did yesterday. I'm cubing the entire side of my equation, which means over here when I cube 13.4, I end up with 2,406.104. I'm going out to the thousands place because eventually I'll round at the end, but I want to make sure I have enough decimal places here. Remember, you have to cube the 5.825, okay, as well. So when I cube that, I end up with 197.646. And when I cube the radical, I just end up with what's under the radical, which was 3590 over P. If I multiply both sides of my equation by P, I'm going to write it up here, I end up with 2406.104 P is equal to 197.646 times 3590. Okay, I can multiply that out. 2406.104 P. When I multiply those together, I end up with 709,548.747. And if I just divide both sides by this 2406.104 and 2406.104, I will get a value for P. P comes out to be approximately, it says round to the nearest horsepower, comes out to be about 295 horsepower. Okay, so it's very straightforward. Let me just fix that. This 3 is the cube root. It's not just some 3 that's kind of hanging out there. That's with the 3. That's the cube root of that. Okay, so remember, you're raising both sides of your equation to the third power because you have a cube root, and you have to make sure you cube everything in that equation. So that is some practice on those. That'll help you finish the sheet that is due today. There is one problem on the sheet that has radicals on both sides. That's problem number 13. Okay, in problem number 13, you are going to in problem number 13, I'll give you a little hint here. You have the square root of x plus 7 is greater than or equal to the square root of 2x plus 1. Or sorry, 2x minus 1. You are going to square both sides of your inequality to get rid of your radicals. Square both sides. You get x plus 7 is greater than or equal to 2x minus 1. I'll leave you to solve that. But remember that x plus 7 has to be greater than or equal to 0. And 2x minus 1 also has to be greater than or equal to 0. Because you can't have negatives under either of those radicals. So here, you get x is greater than negative 7. Here, you get x is greater than or equal to 1/2. Okay, what you need to do here, and I want to be really, really clear about this, you want to take the one that is more restrictive. And what that means is this. Between these two, if I just use this one, if I just use x minus 7, then if I plug any of those values in here, let me explain what I mean. If I have this number line, here's negative 7, here's 0, here's 1/2. I know it's not to scale, but just to give you an idea. I want to take what's more restrictive. This one is more restrictive because it includes less solutions, right? It starts here and goes on forever, right? It starts here and goes on forever, where this one starts back here. This one starts back here and goes on forever. The problem is if I take anything from negative 7 to 1/2, if I take anything in there, it's going to make this radical negative, what's under this radical negative. So I can't use those values. I have to take the one that's more restrictive, which is x is greater than or equal to 1/2. And I said I wasn't going to finish this, but I'll walk you through the rest of it. If I solve this, I end up with x is less than or equal to 8. Okay? So I have x is less than or equal to 8, and here I have x is greater than or equal to 1/2. And those are the two parts of my solution. Because I can't use negative 7, x is greater than negative 7. Because if I choose a value in here, so let's just say I chose 0, and I plug 0 into the right-hand side here, I would end up with a negative 1 under the radical, and I can't have that. So I have to pick the one that's more restrictive, which is this one. So my solution then is going to be x is greater than or equal to 1/2 and x is less than or equal to 8. Or you can write it as 1/2 is less than or equal to x is less than or equal to 8. Okay, hopefully that was helpful for you. That was a little bit of a freebie there. I walked you through that one. So you only have 3 problems to do that are inequalities. There's a word problem on there, and there are 10 radical equation problems. In the word problem that's on your sheet, they give you a fractional exponent. So see how you do with that. If you don't get it, don't worry about it, but try it. Hopefully that'll go okay for you. I'm not going to take off points if you get it wrong, but I do want you to try it. Okay, everybody, that's it. Have a great day. We'll see you next time. Take care. Bye-bye.